Hello everyone, I hope you're doing well. So in this video, I'm going to discuss the solutions for Codeforces Educational Round 134, which was rated for Division 2. So let us quickly start with the first question. So the first question says that we have been given an image of size 2 cross 2 and it consists of 4 pixels. Now the value of the pixels can be one of the 26 characters in lowercase. As you can see, these are the characters present. So we have to now what we can do is we can select at most 2 pixels of the same color. At most 2 pixels means you can select either one color or select one pixel or select 2 pixels of the same color and convert both of them to another color, and both of them should be of the same color. If you read the problem statement, this is what it says, right? You can change one color to other color, or you can select 2 pixels of the same color and change it to another color, and both the pixels should be of the same color. Now this question can be done with a little bit of casework, and if you can see and if you carefully read the test cases, all the cases that are possible in this particular questions are covered in the sample test cases only. So let us consider this particular case when two of them are same, like if R and PP. If the number of unique characters, if the number of unique characters is 2, right? These two are same and these two are same. Then you can select these two and convert these two to these two numbers, or you can do the reverse also. So in one step, I can do it like this. So in this case, the answer would be simply 1, right? Now consider another case. Now here the number of unique characters are 3. It is WB. So what I can do is I can select this particular character and convert it into C, and then select this particular character and convert it into C. So in this case, the answer would be 2. The third case is when all the characters are same and the number of unique characters is 1. In this case, they are already same, so I don't need to do anything, and the answer will be 0. And there's this case where all the characters are present or different, and the last case is exactly same as the first case, right? Because two characters of the same color and the two are again of the same color. So in this particular case where all of them are different, what you can do is A, B, C and D. You can solve it in 3 number of moves. Now you can solve it, you can convert it into like some color B, right? And then you can convert these two into some color B, so that all of them would be same, and this would require 3 number of steps, right? So if you observe one thing very carefully, there's a pattern. Either you can do casework, or you can do if you observe them carefully, you can see that the answer is always number of unique elements minus 1. You can solve this question by writing if else conditions for all the cases, because these would be the only 4 cases that are possible. Either the number of unique elements is 1, either they are 2, 3 or 4. These are the only possible 4 cases. Either you can write if else statements for all of them, or you can just simply print number of unique elements minus 1, because this is the answer in every case if you go by observation, right? So this is what I have done exactly in the code. I have taken a set of characters, and then I take 4 inputs, in which in each input I just take a character A and store it in the set. Now I just print size of set minus 1, because set contains unique elements. So s dot size will denote the number of unique characters taken in the input, and minus 1, if I do it, this will be the final answer, right? So this is how you can easily solve the first question of today's contest. Moving on to the second question. Now this particular question says that you have been given a grid of n into m, right? And you are currently in the cell 1 comma 1, and you want to go to the cell n comma m. Now there is a problem that and one more thing, that you can visit any of the adjacent cells, and let's say it takes one move, right, or one step to move to an adjacent cell, right? Now there's a problem that at point sx comma sy there is a deadly laser, and any point which is at a distance of less than or equal to d from this particular point is dangerous, right? You cannot enter that particular point, right? So this is the formula where from which you can calculate the distance. It is the Manhattan distance, which we generally use So it's the absolute value of x1 minus x2 and the plus absolute value of y1 minus y2. So you cannot enter any cell which has a Manhattan distance of less than or equal to d from this particular point, right? And now you have to find the smallest number of steps or the smallest number of moves to reach the n into n comma mth cell. So if me just show you with an example, if I have a grid, there's a very intuitive approach to this particular question, and it says that, for example, this is some grid and you are present here at this particular cell, and this is your goal to reach here. Now if the bomb or the laser lies in any of the cells, like it must be in this particular area, right? It must be somewhere here, or it can be here also, right? If the bomb is lying like this, anywhere in this area, the most optimal approach is to stay away from the bombs and travel across the perimeter, right? If the bomb is lying anywhere in this grid, the most optimal or the most the safest approach would be to travel across the perimeter. This is the most the first thought that comes to our mind. If there is a bomb, then we need to stay away from it and we can travel across the border or the perimeter of this grid, right? Now what happens is, if the bomb, for let's say if the bomb is placed here, right, and it is cutting this particular grid, right? This grid is not safe, and it is also cutting this particular grid. Now if it is cutting both of the paths at the same time, what it will do is it will cut the whole grid into two halves and you can never reach your goal, right? So this is our claim. But if the bomb is present anywhere like this and it is cutting only one path, right, and the other path is free, then you can always take the other path. So our final claim is it is always optimal to take the border or to travel across the perimeter, and if you cannot travel across either of those perimeter, then the answer would be -1, because if the bomb is cutting both of the paths together, that means that the whole grid has been cut into two half and you can never reach your goal, and then in that case your answer would be -1. If traveling across either of those paths is possible, then the answer would be n plus m minus 2. So I don't need to explain this, because for example, it is 3 into 1, 2, 3, 4, 5. 3 into 5, then in 2 steps you can reach here, and in 4 steps you can reach here, right? So it is always n plus m minus 2. So this is what we can do in our code. So I have taken all the 5 values as input, and I have declared two Boolean variables, valid 1 and valid 2. So I travel across, so I'm taking I is equals to 1 and going up to m. So there are m columns. So in the first loop, I am traversing this particular line, right, and this particular line for each of the valids. So valid 1 is going through 1 comma I, and valid 2 is going through n comma I. 1 comma I is this particular row, this is 1, and this is n, and n comma I is this particular row. I am checking both of them at the same time. And what does my valid function do? Let me show you my valid function. So I am calculating the Manhattan distance, which is x minus xx. Xx and yy is the position of the bomb or the laser, right? I am taking the absolute, and absolute, if it is less than or equal to d, then I will return false or 0, otherwise I will return true, right? And I am taking and of all the values of along the path, because even if one of them is 0, then this path is not valid, right? And similarly I'll do for the height as well. I'm taking a loop from 1 to n plus 1. So I'm in the second loop, I'm taking this particular line and this particular line. So what I'm doing is valid 1 is equals to valid 1 and this particular part, I comma m and I comma 1. So I comma m is this particular row, this particular column, and I comma 1 is this particular column. So I'm checking this path and this path. If either of those paths, either valid 1 is true or valid 2 is true, then I can print the answer, otherwise I'll print -1. So this is the solution for the second question of today's contest. Now let us move on to the third question. The third question says that we have been given two arrays which are in non-decreasing order, right? Now the second array has been formed by adding some values to the first array. So bi would be equal to ai plus di, right? Now our task is to calculate the minimum and the maximum value for each d. For each d means for d0, d1, for each di, we have to calculate the minimum and the maximum possible values. For example, in this case, like this is 2. So you can either form 7 from 2 by adding 5. 5 plus 2 would be 7. Or you can form 13 from 2 by adding 11. Right? So both of them are possible. Now let me just show you how this question will work. Let us take the last example, which is 10, 20, 30, 40. So I'll quickly write them: 10, 20, 30, 40, and 22, 33, and 55. Right. If you carefully observe that, then the question mentions that each di is a non-negative integer. Here it is written. Right. So this means I cannot form 33 from 40. Right, because I cannot add a non-negative integer to 40 to make it 33, because 33 is less than 40, right? But I can make 55 from 40, right? So this is my very first claim, that I can make another integer of the array b only if that value is greater than or equal to the current value of array a. Right. So this is my very first claim that I need to mention. Now, if this particular 40 cannot take a value from here, so it is not allowed to take any value from here. If it cannot take 33, it can definitely not take any value less than 33. Right. So if this is not possible for 33, for 40, if these values are not possible for 40, then this particular value should not be possible for any of these numbers, right? If 40 is not allowed to touch these numbers, then the numbers in the array a should also not be allowed to touch 55, because if they touch 55, they can actually form the sum 55, but if they form it, then 40 will have no place to go, right? So 40 will have no place to go, and this way we cannot form the final array b. Right. So we need to take care that if 40 cannot access these elements, then these elements in array A should also not access this particular element. So what we can do is we can traverse from the back and check what all elements can the number at the ith position can access. Right. So let me write another case here. 10, 18, 20, 33, 30, 33, and 40, 55. So 40 cannot access 33. So this is restricted for all these numbers, right? Now 30 can access 18, 13 cannot access 18, 30 can access 33, and 30 can access 33. Again, 20 cannot access 18, 20 can access 33, and 20 can access 33. So as soon as the last possible number for the ith index is also at the ith index of array B, it means that this is the last number that I can form from this number. Like 33 in this list is the last number, is the smallest number in fact, which I can form from 20. And if the index of both of these numbers are same, then the maximum numbers for this all the numbers smaller than it would be restricted to this particular line, right? Because 30 can form 33 and 20 can form 33, they can exchange their values in between, but 20 cannot access 18, so 10 should also not be allowed to access 33. So I can form a partition here. So what I'm doing is I'm restricting the maximum value which any number can form, right? So 10 at max can form 18, right? 10 at maximum can only form 18, and 20 at maximum can form 33, and at minimum it can form 33 only. So as soon as I find at any index that this is the smallest number that I can form is also at the same index, what I can do is for all the remaining elements, I can mark the maximum index as I minus 1. So initially the maximum index that I can form is at position n minus 1. But as soon as the index of these two are same, I will put this as n minus 2. It will come here. This is the maximum value that it can form. Again, when 20 and 33 are at the same index, then the maximum value will be n minus 4. Right. So this is how the loop will go on. We can start traversing from the end, from the right side, and traverse to the left. And whenever we find that the element, the minimum element that we can form is at the same index as the current element, what we can do is we can restrict the positions or the maximum value that all the other smaller elements and the current element can have. So let us quickly look at the code. So here is the code. What I have done is I have created two vectors of size n and I have taken input in the vectors. Right. Now I make two new vectors, which is result A and result B. Actually result A storing the minimum value and the result B storing the maximum value. Now I store the index of the maximum element that I can have, and that is stored in max variable. Right. So for each element, what I do is I apply binary search to find the smallest element that I can have with the current element. So for the maximum element, max will always max because this is always true. And for the lower bound, I take -1 because this will be always false. And I use binary search to find the smallest element that is greater than equal to the current element. Right. As soon as I find it, what I do is the minimum value of D would be this particular element minus A of I, and the maximum value of D would be the maximum element I can form for the current index minus the current value. And if the index of the smallest value that I can take for the current element is equal to the index of the current element, then I will decrease or I will restrict the index of the maximum element. I will mark it as I minus 1, and at the end I just print both of these arrays. So this is how the solution for the third question works. I hope you guys were able to understand the solutions, and until the next video drops, keep coding, stay safe, bye bye.